Welcome to the next page of our notes here. What we're going to do is we're going to continue this idea, this theme of talking about polynomials. Just a few additional things I want to go over with you here about polynomials that hopefully you learned in Algebra 1. But again, if you didn't, don't worry about it too much. We do have an entire chapter on polynomials coming up later on here in Algebra 2. We want to talk about the degrees of these polynomials, how you figure out the degrees of the terms, the polynomial as a whole, or just a variable. And so that's where we start. We start off with figuring out the degree of a variable, and what our definition says is that you can find the degree of the variable by just simply looking at the power that it's raised to. Let me highlight that for you. All you need to know is what power the variable is raised to. So very, very simple. Just look at the variable, look at what power it is raised to, and you will know the degree of the variable. Now, the next one is to figure out the degree of the term, and once again, very simple arithmetic here. All you're going to need to do is sum the degrees of the variables in the term, right? We're just going to add up all of the powers. It's just that simple. Add all of the powers. And then finally, to find the degree of a polynomial, again, very, very simple. It turns out that it is going to be the same as the largest degree of any one term in the polynomial. So once you find the term that is the largest degree, right, whatever term has the largest degree, that will also be the degree of your polynomial. Let's practice a couple of these. What I'm going to do is I'm just going to flip back to the previous page that we were just on in our notes, and we have these polynomials that I had already given you. There they are. The polynomials that I had given you before. What we're going to do is let's go ahead and see if we can figure out what are the degrees of these polynomials. So here we go. Let me make it a little bit bigger for you so you can see. And this is what we're going to do. Let's go through and first figure out the degree of each of the terms. Now, in my first one, and if you want to go ahead and work ahead on this, again, just feel free to come back, check your answers, make sure that you did it correctly. So if you have already worked ahead and you're coming back, here we go. The degree of the first term is going to be a 2, because that is the degree of my variable, right? Degree of my variable. I don't have a variable in the second one, which means that it is of 0 degree. I don't have any variables. And so now in order to find the degree of my polynomial, I simply take the largest degree term, which in this case turns out to be 2. So this would be a second degree polynomial. Second degree polynomial. Apologize, I'm writing in green. Let me switch that. I will switch to black. Hopefully you can see that. If you can't, I apologize. I'm switching to hopefully a color you can see a little bit better. Okay, in the next one, again, I have a 2-term polynomial. I need to figure out the degree of each of the terms, and I just simply look at the exponents. This is going to be a second degree term. This is going to be a 0 degree term, and in order to figure out the degree of the polynomial, I take the biggest one. Once again, we have a second degree. All right, let's keep going. In the next one, now I'm up to a trinomial. I have 3 terms here, and I'm actually going to have to do a little bit more work on one of these terms. The first one is fairly straightforward. Once again, all I have to do is take a look at the degree on the variable, which turns out to be a 3, so third degree term. In the next one, though, I have more than one variable, and remember our definition said all you need to do is simply sum together, sum all of the powers. Well, I have m to the second and p to the first, and 2 plus 1 would, of course, be 3. Oh, that is a terrible 3. 1 second. There we go. There's my 3. And then my 8, this last term over here, doesn't have a variable with it. 0 degree. And I'm going to run out of space if I write it over in here, so I'm just going to put it right over here for you guys. Pick the biggest degree. It doesn't matter that 2 of them are the same. You only need 1 of them. This is a third degree polynomial. All right, very good. We have one more to go. Let's see how this one works out for us. Again, I got to figure out the degree of each of the terms. Y is to the first, X is to the second. Add them together. I have a third degree term. My second term in my binomial, it's a binomial, I have two terms. My second term, y to the third and x to the fourth, 3 plus 1 would be 4. And that leaves me with a fourth degree polynomial. That gives you a little bit of practice when it comes to finding the degree of a variable, the degree of a term, and then the degree overall of a polynomial. Let me go back to the page that we were originally on in our notes, and we're going to go ahead and finish this up here by just quickly giving you guys, or referring here to the order of operations. Now, when it comes to the order of operations, again, these are going to be the rules that we follow when evaluating an expression. All right, this is just simply to make sure that everybody does it the same way. So what we're going to be doing here with these the order of operations, you can actually almost, if you want, think of them kind of like rules of the road when you're driving. There are several rules that everybody follows, and it helps avoid there being accidents. One that comes to mind just thinking about it is what happens when more than one driver comes to a four-way stop at the same time. Well, who goes first? Of course, we have a rule that tells us the person to the right has the right of way. And just by following those rules, we help to avoid accidents. The same is going to be true here when it comes to the order of operations. And they're just simply rules so that we all follow, or when we all follow these rules, it just assures us that we're all going to get the same answer, which is exactly what we want. Math would be far more confusing if we were all getting different answers. Okay, so, sorry, jump forward on you there. Let's take a look here at what those rules are. Again, I'm not going to spend a ton of time here because you should already be familiar with the rules, but the order of operations is going to be, we're going to evaluate everything inside of grouping symbols, and I do want to make a quick note here. I've got this extra little note down here. When it comes to a fraction, you need to consider the numerator and the denominator as a group. All right, so if you have an expression with a fraction, a numerator and a denominator, the numerator is a group, do all of your work in the top. The denominator is a group, do all of your work in the bottom, and then you can take care of your division. So when we're talking about evaluating expressions, you take care of everything inside the grouping symbols. Don't forget about fractions. Once you've taken care of all of that, you will then go on to evaluate the powers. Once you've taken care of powers, we will multiply and divide from left to right, and you will then, after you've taken care of all that, you will add and subtract from left to right. That takes care of everything on this page. What we're going to do on the next page is we'll get some practice with evaluating expressions. So I'll see you over there on the next page. Meet you there.